Welcome back, 4th grade. Going to keep up with customary measurements some more today. So we've already done customary measurements of distance. So today we're going to work on customary units of weight. So if you would, please make this the title of your next free page in your math notebook. After you have done that, mark your page with a pencil, close it up, and give me lots of concentration until we get to we do. Alright, so we've already talked about metric units of weight. We started talking about the customary system yesterday. So metric units of weight, remember they were the grams was the base unit. So we had kilograms, King Henry, hectograms, which nobody uses, decagrams, which nobody uses, grams, which are very common, decigrams, which nobody uses, centigrams, which are rarely used but occasionally, and then milligrams, which are frequently used. They're very light. Remember, a gram was about a paper clip. A kilogram was like a full water bottle. And a milligram was just really, really small. We talked about it like being in units of medicine. And the math was very easy with that because just like anything with the metric system, anytime we went from one unit to the next, we just had to multiply by 10. So I'm not using my slate, I'm using my mouse because my slate's dead, so my handwriting's going to be bad. Times 10, times 10, times 10, times 10, times 10. And as we learned yesterday, we can still use this system where we multiply as we go down to smaller units, but we can't just do 10 in the customary system. So let's start by talking about what the customary units of measurement are. So the main one that you're familiar with is probably the pound. You probably know how many pounds you weigh, and most things that are weighed are measured in pounds, unless they're very small or very large. We tend to use pounds. So a pound, if you want to try to imagine some things that are a pound, a can of soup is a good example. You know, not too big. You know, a full water bottle is a kilogram, which is more than a pound, but about a can of soup's a pound. Butter, like 4 sticks of butter, if you buy butter that way, it's often sold in a pound. And a football also weighs about a pound. So you want to imagine, if you know any of those, about how much any of those things weigh. If you don't have know how much any of those things weigh, your water bottle that I showed you that probably weighed about a kilogram when it was full, if you made it about 1/3 full, it would probably weigh a pound. So a water bottle that you are, only about 1/3 full. So it's, it's not a whole lot of weight, but it's the main thing. So things that are really big in the customary system, we measure in tons. I know a ton seems like it's not like a real measurement. We're like, oh man, I ate a ton of pizza. We use it as a word that just means a lot. I have tons of colored pencils. But it actually is a measurement too. A ton, officially the word ton is 2,000 pounds. So we might measure something like the weight of a car in tons. I think cars typically weigh about 2 tons, not 1. Small car like mine might only weigh 1 ton. I don't know. But so very, very big things you might weigh in tons. But again, you're talking 2,000 pounds to make a ton. So they're a big, big, big unit. Very small things we weigh in ounces. So 16 ounces make a pound. So an ounce is 1/16 of a pound. So quite small. Some things that weigh about an ounce or a couple of ounces might be like a baby bird or a coin or a piece of bread. Not the whole thing of bread, like one piece. So an ounce is pretty small. So we measure small things in ounces, big things in pounds. So when we set up, I wish we could do a nice easy math. King Henry died drinking chocolate milk, but of course we can't. So the setup here from largest to smallest would be tons, then pounds, then ounces. And when we do the math on that, tons to pounds is going to be times 2,000, which sounds bad, but it's actually not, because you really only have to multiply by the 2 and then just put the zeros on the end. So it's not like yesterday where we had to do 5,280. And then pounds to ounces is times 16, which is a pain. There's no shortcut to multiplying by 16. So when we do our math on the examples, that's going to be our units as we work that out. Okay? So let's do an I do example together along those lines. So a dump truck weighs about 2 tons. How many pounds and ounces does it weigh? Okay, so just like I typed on the last page, I like to, just like King Henry died drinking chocolate milk, the biggest units, the kilos, are on the top, smallest are on the bottom. So I like to list all my units like I taught you yesterday whether or not I'm going to use them. So the largest is tons, the next largest is pounds, and the lowest is ounces. And notice you've got the conversions up here. You rarely will have to have these memorized. These will be given to you, so you don't have to remember. So we're starting with tons. So a dump truck weighs about 2 tons. So I'm going to put that here. And I want to know how many pounds and ounces that weighs. So we're going to measure it in all 3 units, the same 2-ton dump truck. 2-ton dump truck. So the conversion from tons to pounds is times 2,000. There are 2,000 pounds in each ton. So if 1 ton is 2,000 pounds, 2 tons is 4,000 pounds. Again, sorry for the handwriting. I'm trying to write with my mouse. My slate is dead. So the dump truck weighs 2 tons or it weighs 4,000 pounds. Again, always remember these are the same amount of weight. It's just in 2 different units. Big unit, small number, small unit, big number. And we're going to get even bigger when we multiply this by 16, because 16 ounces are in 1 pound. So this is really going to be something to set up. Here's what I'm going to do. I'm just going to do 16 times 4, and then I'm going to add the zeros. So I'm going to set up something to help me multiply 16 times 4. So I'll do an area model like that. Instead of doing 4 zeros, I guess I could do all those zeros just to show you that it won't matter, couldn't I? So 4,000, no hundreds, no tens, no ones in my area model. So here we go. This is going to be a bit hard for numbers for me to fit in these boxes. 4,000 times 10. 4 times 1 is 4, and I'm going to need a bunch of zeros. 1, 2, 3, 4 zeros. I don't even know if I can fit them. 1, 2, 3, 4. Got it. 40,000. And then 4,000 times 6. 6 times 4 is 24. And then 1, 2, 3 zeros from here. 10 times 0 is 0. 6 times 0 is 0. 10 times 0 is 0. 6 times 0 is 0. 10 times 0 is 0. 6 times 0 is 0. None of that mattered. So I've got 40,000 plus 24,000, which when I add together will be 64,000 ounces. So that same dump truck I could measure in tons, I could measure it in pounds, I could measure it in ounces. I get very different numbers, right? Big unit, small number. Small unit, big number. It takes a lot of these to make 2 tons, a lot of ounces. Okay, go ahead and open your math notebook and let's do 2 things together. One is let's list the weights. So you have these in your notebook. So make sure you take some notes real quick on what is a ton, what is a pound, and what is an ounce. Write down some things that weigh that much so you can remember. I don't want you just doing math and being like, I have no idea what an ounce is, but I can do the math. I want you to at least have some idea. Like, oh yeah, maybe holding a couple of coins. And make sure you write these as well, the conversions. 2,000 pounds make a ton, and 16 ounces make a pound. So pause now and go ahead and write those down first, and then we'll do a redo math example. All right, rice is sold in 5-pound bags. People usually eat about 2 ounces of rice for 1 meal. How many meals can I make out of that bag? Oof, this is going to be a multi-step problem. You can tell this isn't just a simple convert the rice to ounces or anything like that. There's a little bit more to this that we're going to have to do. So I do know I'm going to have to do some converting, so I'm going to go ahead and set that up first. I know the biggest unit is tons. The next biggest unit is pounds. The next biggest unit is ounces. And as we talked about before, the converting is going to go like this. 2,000 tons. 2,000 pounds makes a ton. We're not going to need that one, but I'm going to go ahead and write it because there's nothing to do with tons in this problem. And then pounds to ounces is times 16. All right, so one of the hard parts about this problem is I'm given a bag of rice in pounds, but a serving of rice in ounces. So I don't want to have those be separate units because then all my math is kind of going to be for nothing. So I think the first thing I'm going to do is just go ahead and see if I'm going 2 ounces at a time. Let's just see how many ounces this is. And that I think will make the problem much easier to do. So we're starting with 5 pounds, converting to ounces, so 5 times 16. 5 times 16 is 50 and 30. So it looks like this bag is 80 ounces. Actually, now this problem is not all that hard to do. Once I switch from pounds to ounces there, if I just read the problem like this, rice is sold in 80-ounce bags. People usually eat about 2 ounces of rice for one meal. So now I just say, oh, well, I've got 80 ounces, and I'm dividing that into 2-ounce servings. So 80 divided by 2, that's something I'm able to do in my head. And it looks like I can serve about 40 meals from the 5-pound bag of rice. Again, the problem was impossible when it was a 5-pound bag of rice. It was quite easy once we changed it to an 80-ounce bag of rice, because then I have ounces here, I have ounces here, everything quite simple to do. Okay, so that is how you do problems involving customary measurements of weight. So we have done customary measurements of weight, we've done customary measurements of distance. The last thing to do will be customary measurements of capacity. Remember, that's like how much liquid a bottle holds, will be in the next one. So if this was tough, please go back and review these examples again so you're all ready for class tomorrow and feeling strong. Once you feel like you have a good handle on this, you're all done. See you tomorrow.